So this is experiment 1 lecture. Recrystallization. This is a way of purifying. You use it to purify organic products. Whenever you have a reaction, after you do a reaction, you're gonna end up with mixtures. So those mixtures can be separated. One way is recrystallization, where you can grow crystals for one of the product. Let's say you have compound A, B, and C. If B can crystallize and A and C stays as a liquid, you take advantage of that and crystallize this. Alternatively, you might have stock compound in your lab sitting in a bottle, but it gets contaminated with something else, let's say sand. Okay, so you have your sample compound plus sand. What you can do is to dissolve the whole thing. Your sample will dissolve, the sand will not dissolve in your solvent. Okay, so you choose a solvent, dissolve the whole thing in a solvent, the sand does not dissolve. Then you can filter, right? The sand will be filtered out and your liquid containing your sample will flow through, and then now from here you can cool the liquid to grow the crystals, and those crystals can again be filtered out. So that's the process how we're going to collect our crystals of benzoic acid from its mixture with carbon. So our sample will contain benzoic acid. It's gonna also contain carbon. It's called decolorizing carbon. The decolorizing carbon is used to remove color impurities. It might be having some sand. So our lab coordinator already intentionally mixed your pure benzoic acid with decolorizing carbon, which might contain some sand. So the goal is to bring out the benzoic acid from this mixture. It dissolves in hot water but not cold water. Carbon and sand never dissolves in cold or hot water. So we're gonna do two types of filtrations, hot filtration, and the final one will be cold vacuum filtration. That's the overview. So let's dig in. This is what we'll be doing today. That's what I just described. You can otherwise use sublimation. If you have dry ice mixed with some sand, if you just heat it up a little bit or just put it on top of the desk, what happens is that the dry ice will vaporize from solid state to gaseous state. So that's sublimation, transformation from solid directly to gas. That's sublimation. And then this can be collected on a cooler surface, right? As what we call a sublimate, it goes back to solid. So let's say you have cold water on a watch glass. As the gaseous dry ice goes up, it collects on the cold surface, it becomes solid again. So that's sublimation, from solid to gas, and then from gas to solid, that's called it's called sedimentation. Okay. The other method of purification is extraction, and this is just where you use solvents to take out organic molecules from inorganic. You use an organic solvent and aqueous solvent. Another one is chromatography, which is the second experiment, which I'll discuss after this lecture, which you'll do tomorrow too, which you'll do on Thursday too. And then the other one is distillation, which you'll do before midterm, where you're separating two liquids based on boiling point. So the goal is to get a pure compound. Okay? What's a pure compound? That's a compound that is uniform throughout. It has the same type of molecules. We call it homo. Homo meaning the same genus type, same type of molecules in the sample. Most of the time, pure compounds will always give you pure spectrum. In organic too, you'll talk about NMR spectra, IR spectra, and all those things. And so we can characterize it by its physical properties other than using NMR, which are instruments, or IR, nuclear magnetic resonance, or infrared, or even mass spec. Those are instruments we use to judge for purity. You don't see foreign peaks in the spectra. You can also use physical properties other than using the instruments. So one of the physical property is melting point. Because of COVID, timetable and scheduling, you'll not do this experiment. Usually melting point is the second experiment. Okay, so the melting point must be narrow. So like for benzoic acid, the melting point is 122 degrees. So if you are to run its melting point using the instrument, it starts melting at 121. By 122 degrees, it finishes melting. So that's the narrow melting point, which characterizes a pure compound. So to do recrystallization, you're gonna need a solvent. So the process involved you dissolving the solid in a hot solvent, and you don't want to use much of the solvent. You want to keep the solution saturated. If you've forgotten, the saturated solution is where you have the solvent less than the solute. In other words, you have too much solute in a solvent. Dilute solution is where the solvent amount is greatly added. Like you have too much solvent compared to the solute. That's a dilute solution. Okay, so you want it to be concentrated and in fact saturated, which is a little bit more than concentrated. That way, if you cool the solution, the crystals will crash out, will form. So you cool the solution of the saturated solution and the crystals will crash out and you dissolve. So you have to choose the solvent wisely that will only dissolve the compound at high temperature and not at coarse temperature. So our solvent of choice is H2O because that's going to have a favorable temperature coefficient, meaning H2O dissolves benzoic acid when hot, but it does not dissolve benzoic acid when cold. That's the temperature coefficient. Okay, so it should be, the solid should be insoluble at cold temperatures. That's criteria number one of choosing the solvent. Water passes that criteria because it only dissolves benzoic acid when it's hot, not when cold. The impurities should not dissolve in the solvent at any temperatures. Your impurities today, I said it's carbon or sand particles. Water does not dissolve carbon, water does not dissolve sand, water, whether hot or cold, and that's why we will need to filter them out during hot gravity filtration. Okay, so the process again, if you've forgotten, is to take your sample, put it in a flask with minimal amount, keep it saturated, put it in there, you heat it, only benzoic acid dissolves. So that you you're gonna heat it and add little portions of water until there's no more cloudness. Benzoic acid will dissolve, carbon will not dissolve. So the carbon will give you black specks. You'll see black residue which never dissolves. The sand will just be particles at the base, if any. So while it's hot, okay, while it's hot, you use a fluted filter paper with a stemless funnel. Okay, so there's no stem, it's a stemless funnel or a broken funnel, so to speak. Okay, use a stemless funnel sitting on a beaker. Pour this liquid slowly through this fluted filter paper. You collect the hot liquid, and then you're gonna cool the beaker, cool the liquid, okay, cool to room temperature, and then place it on an ice bath. So if this is chunks of ice, you'll dip your beaker in there. Okay, that allows crystals of dissolved benzoic acid to form. So that's the process. Once these crystals form, you do a second filtration. Remember, this is the first filtration. This is hot gravity filtration. Now, the carbons will be trapped here. The carbons will be trapped on the filter paper. Only benzoic acid and some sugars will pass through. So you don't want the sugars, any other soluble particles. You don't want those. So we cool the hot solution. The dissolved sugars will stay in solution. Benzoic acid crashes out. This time we do cold vacuum filtration. Okay, so in this case you use what we call a Buchner funnel, which is connected to a vacuum. So your crystals will be trapped, and then the liquid passes through. In here you'll have soluble impurities, if any. Soluble impurities. Up here you'll have your crystals of benzoic acid, and then you turn those into me to keep to dry. So this slide is talking about impurities. Impurities should either be insoluble in hot water. So like the carbons are insoluble in hot water. That's why we can trap them or remove them during the first hot gravity filtration. They get trapped on the fluted filter paper, while benzoic acid and soluble impurities goes through in solution, or least moderately soluble in cold solvents. Okay, so we've taken care of the insoluble impurities at this step, and then now you have benzoic acid with soluble impurities. You cool it. Benzoic acid does not dissolve in cold water because of the favorable temperature coefficient. You do a second filtration, okay, and then you're gonna be left with your crystals on the filter paper. This filter paper here must be pre-weighed. I'll talk about that shortly. All right, so just to remind you, we chose the solvent which has a favorable temperature coefficient. That's why we can heat filter, cool filter. Then the impurities, carbon, black specks of carbon are filtered during hot gravity filtration. The soluble impurities are filtered out with the rest of the solvent after the second cold vacuum filtration, where benzoic acid is trapped on the pre-weighed filter paper to be kept for drying. All right, the next criteria for choosing a solvent, it should have the boiling point lower than the melting point of the solute. Water passes this criteria number 3 because the boiling point of water is 100 degrees. The melting point of benzoic acid is 122 degrees. So water passes because it has a low boiling point compared to the melting point of benzoic acid. Next, the solvent must not react with the material being purified, being recrystallized. You don't want the water to react with benzoic acid. It does not react with benzoic acid. The structure of benzoic acid is this. Okay. These two don't react. These two do not react. Water dissolves benzoic acid, but water does not react with benzoic acid. Dissolving is a physical property, it's not a chemical property. Okay. Sometimes you might need to use mixtures of solvents to make sure you crystallize well, but that will not be done in this lab. You might need it for 268. So again, I've explained the process. You weigh the solvent to be purified, put it in a flask. Okay, so that's your flask. You put your solid in the flask, the mixture, the gray mixture, put it in the flask. You add boiling stones. Boiling stones just help so that there will be no crazy boiling of your sample whenever you add the solvent. It helps to control. The boiling stones control boiling. Okay. It avoids superheating or super boiling. You don't want this liquid bumping out. That's why we use boiling stones. It's a safety measure. So you continue adding small amount of solvents while you heat. You only stop adding the solvents while you heat when there is no more cloudiness. All you'll be seeing are specks of undissolved carbon. So after that, you want to filter while hot. So when there's no cloudiness in the solution, you see the black specks. That's when you do hot gravity filtration. Okay, let me write it here. Hot gravity filtration. So it's done when this is ready. Remember what I said, you use a fluted filter paper and a stemless funnel and a beaker. The reason why you want to use a stemless funnel is this. If you use a stemmed funnel while you're doing your filtration, when the mother liquor is just the supersaturated solution of your sample. This solution is the mother liquor. It contains the concentrate. When the mother liquor is passing through, it prematurely cools and it clogs the stem. That's why we use a glass funnel that's already broken. So immediately the liquid reaches this point, it drips down into your flask. We need to avoid premature cooling of the filtrate, which is the liquid passing through the funnel. That's the reason why we're using a stemless funnel. All right. Now, as you pour the liquid here, you realize there's gonna be a white paste. That's why you need to just pour small samples, small portions, because again, your mother liquor is gonna prematurely cool on the filter paper. As you pour it, you want to rinse it with pre-boiled water. So you pour a sample of the boiled water to make sure everything is rinsed down. As you do that, you have to make sure that you don't add too much. Okay, you want to keep this solvent down here saturated so that afterwards when you cool it, you're gonna form crystals. If this solvent is too much, crystals will not form. So you'll be pouring this through here. It's gonna cool. The small sample that you poured in here will cool. You'll see white paste. So you have to use another sample of liquid water, of hot water, to rinse the the fluted filter paper. You rinse your sample down into the flask. Remember, don't use too much. That's why this guy here should be super boiling. So you don't use too much of it to rinse the filter paper. Okay, so after gravity filtration with your fluted filter paper, which means the filter paper is folded and creased. You need it fluted so that it directs your sample down. Okay, the fluted filter paper is sitting on a watch glass, a broken stemless funnel. So as you do that, you rinse it. You keep the solvent hot by rinsing it with hot water. The stuff that remains, you're gonna see black residue on the fluted filter paper. What's the black residue? It's obviously insoluble carbon. Is gonna be trapped there, and any sand will be trapped during hot gravity filtration. All right. So hot gravity filtration helps to remove the black residue. I've repeated myself so much about that. So once you collected your hot filtrate, you know that in there you have benzoic acid that is dissolved in the hot water. Benzoic acid only dissolved in hot water. You may also have soluble impurities. So it's not pure yet. That's why you have to let this guy cool to room temperature. And as it cools, you're gonna see some crystals forming. the soluble impurities will stay in solution. So you cool it to room temperature, called ambient temperature, and then place it on ice bath. You place it on ice bath, which is a big gray tray that I'll put on the bench. Place your beaker on there to make sure that the whole solution is cooled down and that you're making the most amount of benzoic acid, because the goal is to get a lot of benzoic acid, recover a lot of benzoic acid. Okay, so small crystals will form and they'll build up, they'll grow as you cool it, and then after that you're gonna perform your vacuum filtration. Now this filter paper must be pre-weighed. Pre-weighed filter paper is placed on what we call the Buchner funnel. The Buchner funnel has holes underneath, so make sure this filter paper, pre-weighed filter paper, is fitting, and the Buchner funnel is stoppered or is cocked. So this will have a tubing going to your vacuum. So the vacuum is sucking air out of the flask, and as you pour this liquid through here, you're going to collect the liquid down here. As a filtrate, you're going to have any soluble impurities taken out. So you see the process. Hot gravity filtration removed the insoluble carbon and sand, and now this last vacuum, the vacuum filtration is removing the soluble impurities. Okay, and now you can pour through here your crystallized sample, and the benzoic acid will be trapped here. When it's finished, you're gonna take out this filter paper. Okay, so you have, from this step, use a spatula, lift up the filter paper with benzoic acid. Remember, you have to pre-weigh the filter paper, and drop it onto a watch glass. Turn this into me to keep. Okay, now because we are doing 2 experiments, don't come to class, come straight to the lab. The first 1 hour we'll do this, the remaining 2 hours we'll do column chromatography. So the last filtration is vacuum filtration. Remember, the filter must fit on the Buchner funnel. Okay, filter, it must fit on the Buchner funnel. You don't want any spaces because the crystals will escape and they'll pass through into the thick-walled flask. So you want to make sure the filter paper fits on the Buchner funnel. Yep, and then you rinse them with cold amount of water before you drop your filter paper on your watch glass. Turn in the watch glass to me. Label the watch glass with a tape. If your name is Moses Ihachi like me, you put MI and then you put the name benzoic acid, and that's what you'll turn in to me. We'll have to keep it to dry. We're not gonna weigh the sample on Thursday the same day. No, we have to wait until it dries and then we wait. Then you'll subtract. Remember, you weighed the filter paper. You weigh the filter paper. So now if you have your sample with benzoic acid, that after we weigh it when dry, this is gonna be the mass of filter paper plus benzoic acid. You subtract the mass of filter paper by itself, the answer will be the mass of benzoic acid crystals. So that's the process. So let's say the filter paper by itself was 0.1. After weighing with benzoic acid, it turns out to be 0.7 grams. So what will be the mass of benzoic acid? You subtract, the mass of benzoic acid will be 0.6 grams. Okay? Now, if you read your procedure, I think it tells you to start with, what is it? Let me see. How much will you be starting with? Okay, let's assume that your in pure benzoic acid, when you weighed it, let's assume it was 0.5 grams. Okay, this is in pure benzoic acid mixed with carbon. So if you want to calculate your percentage, if you want to calculate the percentage recovery, which will go into your notebook calculation part, you'll take your 0. Let's see. No, I should change this. Let's assume you started with 1.5. We'll see what your procedure says, but let's assume you started with 1.5 in pure benzoic acid. So if you want to calculate the percentage recovery, you'll take your 0.6 grams, you'll take this, divide by the 1.5 grams that you started with, times 100. Do the math. Let me see what the answer will be. Where is my calculator in this old phone? So I'm getting the answer to be 40%. So that will be 40% recovery. Now the question is that a good recovery? We don't know how much Jerry had put in there, so to me that's fine. I would say let your answer be as close to 50% as possible. A recovery of 15% is poor recovery. You lose points on that. So that's the process. So, okay, before you come to class, make sure that you do your pre-lab for this experiment. And remember, okay, you need to watch that. I want to see what you need to complete. So that's the calculations I've talked about. You'll judge your purity by how it looks. You need to see clear needles or white crystals. We will not do the melting point. Okay, let's see. Okay, so let me tell you what I wanted to tell you. Before you come to class, you will need the pre-lab setup as described in the syllabus. Pre-lab notebook setup, notebook pre-lab setup. Remember what that is. You start with your title, you go with the objective, and then table of chemical properties, and then procedures in your words, and then data table if any. I think in this lab we don't have a data table, so just write the title data and observation. You need that. You need all these steps written out. I need the details on the table of chemical properties. I need the procedures. I need the objective. I need the title of the experiment. And then you're just gonna write the data and observation title. You'll proceed from here in lab. Do this for experiment 1. Do this for experiment 2, which is column TLC. Again, before you come tomorrow, make sure you do your pre-lab for experiment 1. For experiment 2, you're gonna do a post-lab. Your pre-lab is already posted on Moodle. If the deadline is passed, I won't extend it. So next, I'm gonna do the lecture for column chromatography. Let me stop this. Let me end this.